thing we're going to look at is even and odd functions. And really, I want you to identify even and odd functions based on either looking at the graph or looking at the data table. And start with even functions. Even functions are symmetric about the y-axis. So really, if you just think about placing a mirror right down the y-axis, you know, is the graph symmetric? You know, are all the points equidistant from on either sides of the y-axis? Are they equidistant from the y-axis? In fact, a neat thing to notice, you know, if I put in the number 2 and look at the output, it is the same output as when I put in the number -2. So something to note is the function value at 2 is equal to the function value at -2, and I think you'll find that on any of these. If I put in 3, I get the same output as if I put in -3. So f of 3 equals f of -3. In general, the function value at any value x is the same as the function value at the opposite. Okay. Another basic here is the absolute value function. Notice I've had to draw a mirror right on the y-axis. It is symmetric about the y-axis. Even if I do, this is actually, I believe, x squared plus 5, but still symmetric about the y-axis. Now, note here, note the one, this graph, it is not symmetric simply because notice that where the origin is. The origin is here, so there's the y-axis, and you can convince yourself, even though the graph seems to be symmetric itself, it's not symmetric about the y-axis, so that is not an even function. And in fact, we can look at this. So if I put in a value 2, that's my output. But if I put in -2, you know, the output actually is way up there. Right? So those are even functions. Be able to pick them out. We actually talked about that in class, looking at the data table of a parabola, and notice the symmetry involved there. So you can also look at the data table, and we'll take a look at that if needed. Right? The next is odd functions. Now, odd functions are rotational symmetry about the origin. Right? So once again, and these, well, they don't have to pass through the origin, but you look at here and just think about picking this graph up and flipping it 180 degrees, left or right. So I'll give you an example here. Let's go ahead and trace over. This is, hopefully you notice that that is a cubic function. And then if I were to grab it, and then what I can do is rotate it. Actually, struggling here. Okay. Oh, there it is. So I rotate left, and then I rotate it left again, and you'll see that the two graphs just line up perfectly. Right? So that's a rotational symmetry about the origin. Now we look at this one to the right, and I believe you'll see that it has rotational symmetry. All right. And the one to the left, once again, we've slid it down. So remember, right there's the origin. So we can't flip this thing around and make it and show that it's rotational symmetry. This one, I think you can convince yourself that you can kind of grab and twist it 180 degrees. Now, the neat thing about odd functions is when I put in a 2 here, obviously I get 2 out. If I put in a -2, I get a -2 out. Same thing, if I put in 5 in x, I get 5 out. If I put in a -5 for x, I get -5 out. You can see the same kind of symmetry over here. All right, so this one, if I put in, if I look at f of x, if I put in the opposite of x and into the function, I get out the opposite of the original function, right? So if I put in f of 2, in this case, I get out positive 2, but f of negative 2, I get out a negative 2, so I get the opposite. So if I put in an opposite for the input, I get an opposite for the output. Even and odd functions, just be able to identify them from the graph.